Alright, so here's another example where we have to find the volume of a solid. So again, the problem states find the volume of the solid obtained by revolving the region bounded by the graphs of y equals x cubed, y equals 8, and x equals 0 about the x-axis. So what I've already done here is I've sketched the function y equals x cubed. So we all know that it goes something like this. And then of course y equals 8 is just a horizontal line that cuts through this graph here. And x equals 0, well, the graph x equals 0 is just this vertical line that you see here in orange. So that's x equals 0. So it looks like I'm talking about this region right here that we're creating. And what I'm going to do now in this problem is rotate it about the y-axis. In all the problems that we've been seeing, we've been rotating about the x-axis. We've been doing something like that where we rotate it around this axis here. But for this problem, it's asking us to rotate it about the y-axis. So what we're going to go ahead and do is now rotate it around this guy right here. Well, think about getting this solid right here, this figure, this region right here, and then rotating it around the x-axis and wrapping it around this axis here. You would kind of create a shape that looks like this. So excuse my bad drawing here. Let me try and draw it a little bit better. Let's see. Let me come up from here. We'd have a figure that maybe looks something like that. And so again, we kind of have this cone, this round cone, very similar to the other example that we just did. And so what I want to do is I want to be able to find the volume of this figure or this solid. So what we're going to do again is picture again taking out your meat cleaver. I've been talking about getting a meat cleaver in all these problems. But again, just think about slicing it. Just think about slicing this shape, in such a way where you cut it and make some type of disc or some type of cylinder. So let me just go ahead and shape this. And again, keep in mind that we have some type of ovalish cylinder, some cylinder. We're assuming it's a perfect cylinder here. So again, this we usually call this delta x, but if you notice this here, since we're doing this with respect to the y-axis, we're going to call this delta y. It has a thickness of a delta y, right? Because we're on the y-axis. So let me go ahead and pull this disk out so we can go ahead and look at it a little bit further. So again, it looks something like this. And again, there's my cylinder. Alright, so we know what the height of this cylinder is. The height of this cylinder is delta y. What I need to figure out though is my radius, right? I need to figure out my radius because again, remember the basic formula is the volume is equal to pi r squared times your height. Well, notice that we can substitute the height and we can write pi r squared delta y. Well, now notice that it's a delta y, so I need my radius in terms of y. Well, if I look here, my radius is the distance from the center to one of the edges. So if I go back to my picture here and I move out to the edge, it looks like I'm going some x distance, right? Some distance of x. Well, I need a formula for x. Well, if I look here, I have y equals x cubed, right? Y equals x cubed. Y equals x cubed. Well, if I take the cube root of both sides, I get, let's see, y to the 1/3 would then be equal to x. So notice that no matter where I'm going, no matter if my radius was way up here, then I'm going to go out x units again. Well, keep in mind that x would be whatever your y value is, whatever this y value is to the 1/3. So my radius for this problem here is y to the 1/3. So I can go ahead and substitute this in. And if I substitute that in, I'll get, I'll get the volume is equal to pi, pi y 1/3. And I'm going to square that. So that's being squared because it's r squared delta y. Now that's nice because it's in terms of one variable. We have this in terms of y. I'm going to clean this up a little bit. The volume here is going to be equal to pi y to the, again, 1/3 squared. We're going to multiply the exponents. We get 2/3 delta y. Now here what I'd like you to do is try and think about what your integral is going to be. what your integral is going to be, because again, remember, we're going to go ahead and cut a bunch of cylinders here. We're going to cut a bunch of cylinders, we're going to slice a bunch of discs. And what I would like to do is I would like for you to add all these discs up. Well, again, we're going to accumulate infinitely many discs. Again, that calls for the integral. So again, the total volume is going to equal the integral. Again, and think about where we're starting here. We're starting from 0. We're starting here at 0. So we're going to start here at 0. And we're going all the way. The highest this thing ever goes is 8. So again, we're going to have the integral from 0 to 8. And again, the whole point is to get the volume for one disk. Well, the volume for one disk is given here. It's simply pi y to the 2/3 dy. But notice that the integral will take care of the accumulation part, adding up all these, right? Adding up all these cylinders that we're creating, or all these disks that we're creating. The integral takes care of that. This here is just the simple volume formula for one single disk, and the integral will take care of accumulating all the disks that we've sliced from 0 to 8. So again, this should be pretty straightforward for you to do. We get, let's see, pi, and then I'm going to add 1. So think about adding 3 over 3. That's going to give us y to the 5/3, y to the 5/3 divided by 5/3, or you can multiply by the reciprocal. So there's the antiderivative, and again, we are going from 0 to 8. And if you evaluate this, and I'll leave that for you to do, you should get an answer of 96 pi over 5 for the volume.